Okay. Just one sec. Okay. Hello, everyone, and welcome to the Cloud Lunch and Learn sessions. My name is Hugo Barona, and today we have the second session of our series of sessions related to blockchain. We have Juarez with us explaining how to use Quorum on Azure Blockchain. I hand over to you, Juarez.
Thank you very much, Hugo. Hi, everyone. Good afternoon. First of all, for those who don't know me, my name is Juarez Barbosa Jr., and I work for Microsoft in Ireland as an Azure Developer Audience Lead. And today, I'll be presenting Quorum on Azure with the different approaches considering Quorum when you compare it to traditional Ethereum blockchain, the classic networks. You can see here my email message as well as my Twitter and Medium handles and my LinkedIn handle as well. So in case you have doubts concerning the session today, please feel free to reach out to me. So without further ado, let's start. So let's talk a little bit about Quorum, what it is and the reasons why it started, okay? So Quorum is a project by JP Morgan Chase, a financial institution in the USA. And Quorum is an implementation of our Ethereum-based distributed ledger protocol, because we are talking about blockchain. But it is actually designed to develop and evolve alongside Ethereum, but it is actually a fork because they implemented some Hugo, I can.
Sorry, it was, someone was on mute. I just muted. Right. You can continue, sorry.
No problems. Yes, but it actually extended Ethereum and actually the Golang client GAF to provide features that are more aligned with the characteristics and the use cases and the requirements presented by enterprise applications. Okay. The first thing, actually, it provides beyond the permissionless, the public blockchain that we have on when you decide to use Ethereum, for example, from my latest presentation in case you participated, but I can talk about again here. Ethereum is actually permissionless, so you don't need to be authorized to join the Ethereum network. You just acquire a hardware box, a server, you install the mining software, and then you can join the Ethereum network. With Quorum, it's a little bit different because, normally enterprises, they don't want to disclose their internal private and business transactions. It's important to protect their businesses and, the core business and the strategy of a given company, for example. So Quorum implements a permissioned Ethereum network, okay? And it improves the support to transaction and contract privacy. The second, I would say, outstanding feature here is about the throughput concerning the processing of those private transactions. Because with Ethereum, the public one, for example, depending on the situation, there might be some network bottlenecks and congestion and things like that. But with Quorum, given that it is permissioned, it's more controlled because you can create what we call a consortium. Okay, and then invite the given business partners to join. So with that, you can achieve, of course, more scalability and also better throughput in terms of the number of private transactions that you can process and address. Okay, Quorum can run with two different privacy options here, Constellation and Tessera, but Constellation, actually, it's not being updated currently. The latest update happened, I guess, a couple of years ago. So Tessera is the current one. The main one, the latest features are being implemented on top of Tessera. It is actually a kind of enclave component for security. So it addresses all the requirements in terms of secure channels, private keys, certificates, key stores, and so on. And it is implemented in Java. You have both links here, so you can have a look later, okay? Just to mention, Quorum is open source. It follows the LGPL 3.0 license, okay? So it's totally extensible. And that's a good thing anyway, because you can also implement, for example, your own consensus algorithm, okay? Because all the components is, you can replace them. The architecture is totally pluggable. From the programming point of view, it uses Solidity, the main language that we have in the scope of Ethereum's ecosystem. Okay, so you can basically reuse your Solidity smart contracts and run them in a Quorum consortium, for example, but with, as I said, with privacy and in a permissioned way. Okay. In case you want to explore all the details about the design rationale and the background concerning Quorum, for example, you also have the link here to the Quorum white paper, where all the details are there. Okay. Let's move here and talk a little bit about then the main benefits. As I said, Quorum is a fork of Go Ethereum, okay, and updated in line with Go Ethereum. So what I'm saying is that although it is a fork, they try to actually follow the upstream open source component provided by Ethereum, okay, and then provide the modifications on top of that. So they try to be aligned, and they are following the latest updates, okay. There are entire teams dedicated to that, and also contributions by the community. The enhancements, as I talked about with a little bit of more detail, okay, it provides the private transactions and privacy to smart contracts as well. It separates the public and private state, because remember, with the classic Ethereum, you only have public data stores and also the public blockchain, but with Quorum, you can also implement the private one, okay? And there's a clear separation in terms of transactions, components, and the Genesis blocks and so on. It uses encrypted messages, of course, okay? So as I explained, for example, Tessera is the component that is the core of our enclave to implement this privacy and the private exchange of blockchain messages. There's actually a REST API between the main component, among the main components that they are called the transaction managers. Peer permissioning, as I explained, in order to join the consortium, for example, then you need to authorize a given external party with the installed node to join this consortium in the network then. Okay, so it's not totally public. Remember, we are talking about permissioned blockchain networks. Interesting to say, it also implements mechanisms, a plugin to allow you to implement account management. I'm talking about user repositories, external votes, and authorization and pluggability, considering external user repositories. And also, in case you want to implement your own, let's say to use OpenLL DApp as the user repository, an open source one, remember the architecture is pluggable, so you can just go and extend the existing components and provide your own concrete implementation. This is also about the next point here, pluggability. Okay, so it's really flexible, and that's one of the main features of Quorum that I can say are really powerful when you consider enterprise applications. Because let's say you have the same situation here, in case you have a mainframe application and you have a user repository running as a COBOL application on the high-end platform, you can, of course, implement a pluggable authentication module component and extend that to target it with, for example, socket connections or Java connector architecture or anything. Many components, by the way, that are part of Quorum, they are implemented in Java. In terms of performance, of course, it's permissioned. So, it starts when you create a consortium, for example, you have a new chain, a new Genesis block, and that helps somehow with performance and the throughput as well. Okay, and there are several improvements in terms of code implementation to, I would say, deliver better performance and throughput when you compare it with the public GAF client. And the consensus mechanisms, that's the best thing, because there's no need to consider or use what we call, the traditional consensus algorithms like in Bitcoin, the proof of work. you know, where you need to, it is really demanding in terms of electrical energy, processor, and also the way that the transactions are processed. There's no need actually to mine to have the mining processes, you know. And the same thing with POS, the proof of stake. You know, it's a little bit different. Even when you consider Ethereum currently, Ethereum is trying to move from proof of work to proof of stake. There are several solutions, for example, at the moment, Casper and different implementations, sharding and so on, to actually allow Ethereum to move to a better consensus mechanism to improve the performance. This is really critical. Ethereum, for example, something like happened back in December 2017. It was experienced, I would say, a spike in terms of transactions and the number of people actually using the network. And the bottleneck and the delays, people experienced delays of 2 hours or more concerning the finality of a given transaction, you know. But the consensus mechanisms available in Quorum, we have the raft-based consensus, okay? It's a consensus model for faster block times, you know, and the transaction finality, you know, the confirmation. And on-demand block creation, it's a little bit different. We also have Istanbul BFT, Byzantine fault tolerance, or PBFT, practical Byzantine fault tolerance. Just to mention, for example, one of the other, I would say, strong competitor concerning permissioned networks and enterprise blockchain is Hyperledger Fabric, and it also uses BFT. There are other options as well, because Hyperledger Fabric now is pluggable more than when it started 4 years ago. But it's good because somehow with Quorum, you can also implement the same approach as you have in Hyperledger Fabric, okay? And there's also this click POA consensus. POA is proof of authority. It's a different consensus algorithm as well. So at the end of the day, the good thing with Quorum is that depending on the network that you want to integrate with or implement, you know, you have many choices concerning the consensus algorithms. Let's talk a little bit about the architecture then. Okay, this is a simplified diagrams block here, block diagram, sorry. So we have here, as I explained, the Quorum node. That's basically the GAF, the Go Ethereum client, a modified version, okay, with the different consensus models. We have what we call the privacy manager, and it is actually composed by the transaction manager. This is actually the central piece concerning the life cycle of a private transaction, for example. Okay, and it controls all the interactions. We can say that the transaction manager is the active component concerning all the orchestration and the solution. We have the enclave. This is actually a way to, it's a design pattern somehow, a software design pattern, because it is a way to separate all the concerns and all the mechanisms that are related to security from the main transaction manager in order to reduce the surface area and, you know, protect the core security component from, I would say, cyber attacks and things like that. And there are other benefits as well. It's about, at the end of the day, you know, separation of concerns as you have in any good software design. And it implements the peer security, as I said. So all the things related to TLS, SSL, HTTPS, security certificates, key stores, and so on, they are implemented then as part of this component. And just to mention, the Tessera component is actually part of this enclave, okay? Let's move here. We have just one quick example here, a high-level overview of how the private transaction works. So we have a consortium here with 3 participant organizations, A, B, and C. Okay, and then we have a proposal for a given transaction between A and B. Okay, so you can see here, for example, that participant C is actually part of this consortium, but it will not participate in this transaction here. And this is actually, there is evidence here, because you can see that the transaction managers here, only participant A and B, they exchange messages here. You know, as I said, they use a REST API and HTTPS to communicate, the transaction managers, but you can see that there's no communication concerning this TX and AB, for example, between B and C here, okay? We have the flow, the private transaction proposal, the transaction payload is sent then to the transaction manager. It has a dependency on the enclave and the SARA component, as I said, concerning encryption and decryption. It receives then the response to process. After that, it stores the information and moves to return the hash to the requesting node, for example. You have an exchange of hashes here, and you can see communication here, for example, and now here it's a little bit different, because although this participant C is not participating in this transaction context here, A and B, you can see that there's communication between C and B here, for example. Why? Because at the end of the day, this transaction is between A and B, but actually we are talking about blockchain. So remember from my initial presentation last week, we have what we can call a shared data ledger, okay, and the collective ownership of data. So given that one transaction is confirmed here, actually node C needs to receive actually a copy of those transactions and the blocks. Okay, so you can see here, for example, the Raft transport protocol for the in case you are using Raft as a consensus mechanisms. Of course, it is performing the replication here. Okay, this is really, I would say, this is just the simple explanation. But in case you want to really extend, you can check this link here as well, with the entire life cycle of a private transaction, with all the details and all the certificates and how the data is encrypted and decrypted, and how the delta in terms of data and everything is calculated. Okay. Let's talk a little bit about Quorum on Azure now. Quorum, actually, last year, back in May, Microsoft announced a partnership with JP Morgan to actually implement Quorum as a managed blockchain solution on top of Azure. So we have this announcement here. It's really a strategy for both Microsoft and JP Morgan. Okay, and we have a couple of choices here. You can run Quorum on Azure, and you can use the VMs. There's a marketplace template that you can reuse, okay? But in that case, we are at the lowest level in terms of cloud architecture, because we are considering IaaS, infrastructure as a service, okay? It's possible, but you have to manage all the components, so the complexity is higher. But it's an option anyway. Okay, we have this template here. So in case you have an existing Quorum on-prem, let's say consortium, for example, and you want to implement that with Azure, that's an option. Okay. But the best option I can say is to use the Azure Blockchain service, because this is actually a service that encapsulates and hides all the complexity, considering the governance, provisioning, certificates, you know, IP management, ports, and smart contracts, storage, backup, you know, all the common, I would say, non-functional requirements of a given software and solutions architecture. And blockchain, at the end of the day, it's technology as well, you know, so you can abstract that. And then we have what we can call, this is an acronym, BaaS, Blockchain as a Service. So the Azure Blockchain Service is a solution that you can use actually to avoid all those complexities in terms of infrastructure, and just focus on the implementation of your smart contracts and the app clients. So we have here all the benefits, as I explained, you know, it's a fully managed blockchain network. So things like security, for example, you have the full security governance and all the coverage, all the updates, they are actually addressed by Microsoft. You can handle scalability and achieve that, you know, because you can provision services and more nodes. You can achieve elasticity depending on the approach. For example, we give you all the tools, for example, so it's easier to actually use the blockchain service. On top of that, we also have several dashboards with all the information about your network, but also the blocks, the transactions, but also the integrations, the endpoints, the smart contracts, everything. It's better because it is consolidated. You have this dashboard with all the information. It's user-friendly. And in case you want to use the plain open source component, for example, or DIS solution, you need to actually, in order to get the number of transactions and blocks and things like that, you need to use several command line tools. So it's not straightforward. Okay, monitoring is implemented as well. So there are many, I would say, advantages when you consider it. Just to mention, beyond the blockchain service, then we also have the blockchain workbench. It's a service that you can use to provision other Azure services to complement Azure Blockchain. At the end of the day, remember, blockchain is just a kind of data store, it's more elaborate, of course. It has security and it implements a data store in a different way with the immutability and many blockchain features, but you need data. So the blockchain workbench, you can provision an environment with the IoT hub, for example, in case you want to ingest data from IoT devices. There we have, for example, the event hub. We have Key Vault, for example, data Active Directory for authentication and the implementation of that administration mechanism and that I talked about. And we have the dev kit. The dev kit is first one extension for VS Code to accelerate the development of smart contracts. And second, we have several code samples as part of DevKit that you can reuse out of the box. Let's talk then a little bit about Quorum and the app development. The app, we call the applications then distributed apps, okay, because we are talking about blockchain, and blockchain, distributed networking and computing is core to blockchain. So you need a number of different tools. Traditionally, for both, not only Quorum, but also Ethereum, we have the Truffle suite. That is actually a set of tools that you can use to compile your smart contract, for example, test it, deploy it, and so on. We have Ganache, and that's a local environment that you can provision. Ganache is actually part of this Truffle suite. That you can use to run locally with no need to deploy, I would say, and to accelerate the development, you can deploy and test the smart contracts locally first, and then move to deploy to the cloud, or depending on your choices. Solidity is the programming language, as I explained. This presentation here, it has all the links, okay, so you can explore later. VS Code as the tool, of course. Along with the blockchain development kit. And Node.js is also a dependency because Truffle, for example, has a dependency on Node.js. You can use, I would say, the native compiler to accelerate the development. But at the end of the day, these are the tools that you need to develop the apps. Okay, let's move here then and have a quick demo. First, I just want to show you how to provision a blockchain network. Okay, so I'm talking about the Azure Blockchain service. You can select create a resource here as usual. You select blockchain and then Azure Blockchain service. Okay, the subscription as usual. You can create or reuse a resource group. And let me actually, I prepared the data here. Let me copy it here just to avoid problems. Okay, let's say this is the resource group. Okay, I can create a new one here as usual. Okay, this is the region. You select the protocol here. In our case, we are talking about Quorum. Okay, the region as usual as well. You have to define a consortium name, okay, where all those participants, they will be consolidated. So let's create a new one here. Okay, let's call it 2021 CS. And you have to decide about the member name. The member is actually the node, okay, for this implementation and the consortium here. Let's call it MN. Okay, you provide member account password. Okay, this is important for the security part. I created one password here. All right. Choices here in terms of deployment and the architecture. This case, for example, I want to provide one validator node and two transaction nodes. Okay, so let's stick to standard. And the last thing, you also need to provide a password for your transaction node. Okay. Perfect. After that, as usual, review and create. It's okay, and then you can start to provision it. All right. But we are not going to wait for it because I provisioned one before the presentation today. So this is the final result, you know, where you can see that we have the protocol with Quorum, we have the member here with 2 cores and 3 nodes, okay? As I specified there, all the information, you have the visibility about, for example, the transactions, the blocks and everything here. You can, for example, and you can use this dashboard here to implement, as I said, the integration with the Active Directory, whole assignment, you know, authorization, authentication, auditing, and so on. Monitoring is here as well. You know, you can configure alerts as usual. You can inspect the logs. We have the data manager, as I explained. We'll have a presentation about the data manager as part of this series, a component that you can use to actually integrate with disparate and external data sources in order to ingest the data and have them on chain to be processed by smart contracts. But those are the steps to provision the blockchain service, okay? The second part is actually show you how to create a Quorum smart contract on VS Code. So let's do it. Okay, so we have VS Code here, but let's start from scratch maybe. Let me close this folder here. All right, so you select open folder here, and then you can create a new project. For example, let's say BC Quorum demo. Okay. It takes a short while, as usual, you know, VS Code. All right, so then I can select here to create a new Solidity project. It is actually activating the blockchain extension. Okay, so it takes a while here. Let's check again here. Okay. All right, create basic project. I select the folder. That's the correct one. Okay. And then it starts to create a project here. Actually, I can actually inspect the, not here, but the output here. Azure Blockchain. Okay, yes. So you can see the tools that I talked about, for example, Ganache and so on. And by the way, I have 3 blog posts where you can see all the steps concerning how to install all the dependencies, all those tools that I talked about, you know. So they are also included as part of this presentation. Yeah, meanwhile, I can perhaps just show that. Yeah, so what I talked about, you know, I have these blog posts here where you can create a blockchain consortium, you know, for So all the steps that I presented here, you know, with all the details and the options here. Okay. Second one, you can, okay, how to deploy a smart contract, the step that we are working on. But before that, you know, you have to install VS Code and also the dev kit, as I explained, you know, Node.js, the right versions, you know, for compatibility, NPM, Git, of course, Python, I forgot to mention, Truffle, Ganache, command line interface. A C++ compiler is required as well. And then we can follow those steps. Let's have a look. Okay, so the project is created here. Okay, you can see a sample smart contract here. I can compile it from, sorry, right click, build contracts, and then it starts. But I can also run the same commands from the command line here. Okay, I can show that later. And then it starts to compile the smart contract. Okay, it worked properly. Same thing, then I can deploy this smart contract. When I go to deploy, first I have to sign on. Yes, this one. Perfect. So I can go back and I can use an existing network. Actually, let me do something here. No, let me just make sure that I'm using the right network. So let me disconnect here. Okay, and then connect. Azure Blockchain service. You can see you select the subscription. Which one is it? This one. Yeah, you select the consortium, the target consortium as well. And you can see the member here. Perfect. All right. So we are ready now. We can then deploy the smart contract. Okay. So right click again, deploy contracts. You select the target network, correct? It's needed, you need to create a mnemonic. It's a kind of file with several keywords that are used to encrypt the the transactions and the information. Okay, and then the deployment process is started here. It is compiling again. Okay, this is the verbose output, so you can see some details here with details about the transaction hash, gas, for example, and so on. Okay, it's almost there. Okay, succeeded. So those are the steps required to create and deploy a Solidity smart contract and deploy them to a Quorum network. I can then call this smart contract, but before that, maybe I can also show you how to compile the smart contracts from the command line. At the end of the day, it's basically the same thing, you know. You let me do it here. CMD. Okay. BC Quorum demo. And then I can run some commands here. So you can see, okay, I can use truffle compile first. And then you can see that all the dependencies, as I explained, for example, Node.js, Truffle, and Ganache, they are all installed. Okay, compile successfully. And then I can move to deploy it with this migrate command and reset here. Let's try it. There are several steps here and verifications, because, and then you can see all the security mechanisms and all the checks happening here. Perfect. But this smart contract is just a scaffold one. So in order to actually call you, I need to perform a quick modification here. So let's do it. I can copy and create a couple of functions here to echo a given message. So I can insert in here after the send response method, for example. Okay. All right. And just to mention, I can also interact with the smart contract from VS Code here. There's an interaction page here where you can see the target methods. For example, you can select the contract in the methods here and then send a message. You can type here something like hello. But before I do that, I have to actually finish here. Let me see. Okay. Let me build it again. Sorry. Okay, let's deploy it again. Same thing, same network, and all the information. You can get this target information here from this file, truffle config, because remember, truffle is the tool that we are using. In case you are using Ganache, we have, as I explained, this local environment here. But in our case, we are targeting a remote environment on Azure. So you can see the URL here with the specific ID, okay? When you perform the integration, actually this wallet here for authentication is created, and that's why you need the mnemonic and so on, and also that authentication step. Let's have a look here. Yes, it is done here. So I can now actually call the smart contract. So first I have to connect to that network. Okay, so let's try here. Perfect. So we have a shell here now, you can see, right? This is specific to truffle. And then I can first call to see the standard message as per the smart contract. All right, hello world. And then I can modify it here. And this is actually a blockchain transaction, so after this message is here, what is stored there is immutable, of course. And then I can retrieve it. Okay, so this is the entire life cycle. Behind the scenes, remember that all those steps concerning the transaction flow, they are happening. As I explained, there are many details here in terms of keys and exchanges and blah, blah, blah. You can have a look later. I have that as part of my documentation. And yes. Okay, so as I explained, the key takeaways here, Azure is a good option when you are considering Quorum because you can use different approaches. You can deploy VMs and operate at the IaaS level, or in case you want, you can also use a BaaS service, a managed one, and avoid all the complexity with blockchain. Because with just a couple of or 3 participant organizations, as I showed here today, it is easy to manage a blockchain network. But when you create a consortium, for example, let's say that I'm a car manufacturer like Honda, for example, and I want to create a consortium to track the cars or the car parts, for example, and I want to invite all my partners, all the providers, all the dealerships, and so on. The number of nodes and participants, you can have an explosion in considering the number of nodes and things like that. So the management and the governance considering this blockchain infrastructure, that can become a separate project. It's not easy, you can go the open source way, but remember that there are many different things that you have to look at. So it's a good option to use a managed service like this one, so you can accelerate the implementation of your Quorum solution. I have here the pointers, for both approaches. The provisioning using the Azure Blockchain Service BaaS, as I explained, and the blog posts are here with links to the official documentation as well, by the way. And also one example, with the documentation that you can get from the Azure Marketplace with all the steps to provision several nodes to a single VM as a kind of demo or test environment. And the examples here, the official ones provided by Quorum, you can explore different smart contracts as well. But that's it. The last thing that I want to show you, maybe just again, walk you through the different links that I presented here today. So we have here the main, where is it? Yeah, this one here. The main website for the Quorum project, it's an open source project anyway, but there are many different, the community and many different enterprise corporations, they are collaborating here. This is the GitHub, the official one, okay, where you have all the components and the explanations here, and different projects that you can use, for example, to support interactions. You can also use the official Docker containers. Let's say that you want to use AKS, Azure Kubernetes Service, to implement a Quorum network and use, a cloud native approach. That's possible as well. Okay, let me close this. Yeah, this one here. Okay, I talked about the Azure Blockchain Service. This is the official page, okay, where you can get all the information, including the official documentation with several use cases here and steps. And you can see here, for example, the explanation about the service, the private consortium, security, development tools. For example, we'll have a presentation about how to use the data manager, for example, and so on, VS Code integration, how to manage the blockchain members from the CLI instead of Azure Portal, for example, or PowerShell. Yes, this is the link for the market, the place where you can get the information about the template and the marketplace template, and the user guide is here. So there's a PDF file here. Actually, I have it here with all the information here. Okay, so let me just show you quickly here. Okay, the explanation here, and then in case you want to give it a try, the IaaS approach, all the steps are here as well. But remember, you have to manage all the components after that, so it's not so easy. Okay. This one is actually one more representation of that architecture. Remember, Go Ethereum GAF is the base here, okay? And then you have Quorum, okay, as a fork and with additional features, considering the transaction manager, the enclave, the consensus, the pluggable consensus algorithms, the network manager, and then you have the apps here on top of that. So this is the documentation. The examples are here, as I explained. You can use Vagrant as well, kind of DevOps tool with VirtualBox, for example, in case you want to use a local environment to test it, I would say dev mode. Tessera, this is the enclave and the security component, as I explained. It's a stateless Java system. And this is the one that is being updated, 17 days here, for example. But if you check Constellation, for example, as I explained, actually not only 2 years, but it's not moving forward anymore. So Tessera is the one to consider for a given Quorum solution. Explanation about the different components then here, in case you want to explore. All those links, they are provided as part of my presentation, okay? And what else? Yeah, the life cycle. The tools that I presented, we have here, yeah, the official Docker Hub Docker images are here as well, in case you want to implement cloud native with, an immutable approach to your environment, Ganache as the environment, Truffle Suite with the explanation about the different tools here. It's an interesting project, open source as well, supported by a company called Consensus. Solidity is the programming language. Okay, so it's a DSL, but somehow you can consider it a full-fledged programming language. So there are many different ways here. It's a kind of mix of JavaScript and Python, and, but it's interesting. The dev kit, the extension for VS Code, and yeah, and that's it. That's everything that I have to present today. Let me hand it over back to you, Ugo.
Yes.
Thanks
Can
a lot.
we just load the slides for the questions, please?
Oh, yes, of course. Sorry.
Yeah, so we actually have here one question for you,
Okay.
provided by Alexandro. So he asks, once a blockchain is deployed in Azure, which XDK can be used to connect the blockchain and see the transaction? So he's asking if there is any API or any SDK available on C#.
Officially, no, but there are some, I would say, indie implementations, not only for C#, but other languages as well, like, Ruby and so on. But concerning the question, it depends on the blockchain protocol that we are talking about, because if we, and also the specific deployment. In the scope of Azure, you can use Solidity to interact with the smart contract. But there are also some other options. Let's say if you are considering different protocols like Hyperledger, for example, you can also use Golang, Java, JavaScript, Python as well. The Python SDK is still not official, finalized, but there's a Python SDK as well. And there's a way to implement a REST API because Quorum also offers a REST interface. Okay, so you can use that. But it depends at the end of the day on the protocol, when we talk about Azure. We'll have the next presentation will be about Hyperledger. So it's totally different components, different approach, different way to implement the smart contracts, different plugins, different everything. So I will provide more details about Hyperledger, and after that, the last session will be exploring Corridor in a couple of weeks. Okay.
Yeah, sounds great. And can we move? Well, actually, we don't have any more questions. I don't know if anyone want to ask anything else. Feel free to unmute or even to drop the questions on the chat. So it looks like not. So, okay. Before we finish, so I want to share with you this event provided by our collaborator, European Cloud Conference. The name of the event is Azure Masterclass Series, and it will be basically a three full days of sessions talking about different topics on Azure, including Kubernetes, AI, and infrastructure as code. It will be from 1st to 3rd of September, and the best of all is for free. So to save your spot, you just need to access their websites listed on the bottom of the slide, so www.europeancloudconference.com, and you should be able to see the details of these events and other upcoming events and register. And we can maybe proceed to the next slide. Juarez, yeah. So, and in case you did not have a chance in the beginning of this session to register to the session, please do it now. You can register to this session using the QR codes or using the link available on these slides, aka.ms. And basically, you just need to fill in a quick form and you will have access to relevant materials related to this session provided by Microsoft. And also it's good for us because we can justify all the efforts on this initiative. And also, I want to let you know that Cloud Lunch and Learn will continue. I will drop in the chats the links for the next sessions. Of course, as Juarez said, next week, next Monday, we'll have the next session on this blockchain series. And Juarez will talk about Hyperledger on Azure Blockchain. And also this Friday, we'll have the next session on the IoT series, explaining how to set up your IoT edge device. And thank you so much, Juarez, for delivering this great session. And thank you everyone to joining us on this session. And please use the link on the chat as well to provide feedback on this session using our survey. And we really appreciate your feedback so we can improve our sessions and ensure we deliver the best as possible.
You are very welcome. And thanks a lot, Hugo, and thanks everyone for joining the session today.
Thank you so
It was a
much.
pleasure for me.
Thank you. Have a great day, all of you. And thank you. And see you on Friday.
Likewise. Thank you. Bye-bye.